This is the experimental setup for today. So we have, did you like the dramatic turn there? I think it worked. I'm going to leave it in. So we have a couple of oscilloscopes. I'm going to demonstrate those for you in a bit. We've got a signal generator up here, which again I'll talk about in a little while. This is our breadboard, and I have a selection of pre-made circuit boards that we'll be seeing throughout the experiment. And this is our drop tower, which was custom made for us by our lab technician Bob, who, you know, did a pretty good job, I think. I have no complaints anyway. And we're going to be using this to measure the acceleration due to gravity at the end of the experiment. This is the breadboard, and this is actually a composite of 3 separate breadboards. And these are basically tools that we use to quickly build circuits without having to connect wires to individual components. So you can make use of this to build and test things really quickly. So basically what you'll see, I'm just going to look at this one board, so in the experiment we'll end up using all 3. You have 2 vertical channels running down each side of the board. So anything that goes into one channel, so if I put something into this slot here, that would go into all of these slots. So it's pretty common to maybe put ground in this rail, and then on the other side you might put 5 volts into this rail, and it would go through all of these. Where the screws are, that marks an end in the breadboard. So if we put 0 volts, like grounding, into this rail, there'd be nothing at all in this one. So we could have separate circuits on kind of 6 segments of the board. You'll see as I build the circuits on this, sometimes I bridge across here just because I need to carry a signal onwards. Likewise, you've got this big channel down the middle. That's another break in the circuits. But if you go horizontally across here, so there's 1, 2, 3, 4, 5 holes here. Anything that goes into one of these holes goes into all 5, but again not into this one. So when I build the first circuit with the LED and so on, you'll see that I have to be a little careful about using that. Okay, so the first thing I've done is wire up the breadboard so that this lower quadrant here, it's not really a quadrant because quadrant means 4, so let's say this lower region here is powered. So I've grounded the external rail there, and I've put 5 volts into the kind of inner rail of this one. I could put it into the outer rail, so I'll just do that. I have color-coded the wires, so I put 0 volts as green because it matches the terminal there, and I've used orange with the blue, partially because I couldn't find blue wires. So, you know, that was a problem. And also because I only really need to differentiate them just so I don't make any mistakes once I have more boards on here and it becomes difficult to see. And hey, unless you're an engineer, it's probably possible to remember that 5 volts is the orange wire in this case. I've also left quite a lot because later on in the experiment I'm going to be wanting to connect up here, and I want to make sure I have enough wire for that. So that's why the wiring's a little ugly looking at the moment. So I've got a few components I'm going to add in. So first of all, I have this very neat push button. I also have a LED, so you'll see that there. And I have a 330 ohm resistor. You can tell by the color coding on that it's a 330. So the resistor is orange, orange, black, brown, which should be 330 times 1. So first thing I want to do, I suppose I should turn the power off for good practice. So I'm going to put the first leg of the resistor into the same rail as the 5 volt line. So this resistor is a little overused. I'm just going to bend the wires so it's a little easier to do. So there we go. So I've got 5 volts going through that leg of the resistor, and then it's coming across to here. And then I'm going to take the LED, which is also a little bent, so let's straighten that as well. And I'm going to put it, so basically one leg of the LED needs to go into one of these 4 holes, and it doesn't matter which one, and then I'm going to take it across the channel here. Now I could build downwards, that would be fine. I could build anywhere kind of that I can fit the legs in, but the one thing I wouldn't want to do is put the both legs of the resistor in there like that, because that would mean effectively both legs of the resistor were in the same kind of potential region, so that would cause it not to light. So let's separate the legs a little. I probably should have phrased that differently. Let's put the resistor across here, the LED across here, like that. Now there should be a flat end of the LED, which tells you which way it'll light. So LEDs, of course, only work one way in a circuit, so we need to watch out for that. And then again, I just need to take one of the one of the pins of the switch, and then connect it across like that. Okay, so I've wired my circuit up. I can now turn on the power there, and of course it's just time to push this button. And I quite like this because I think it looks like the kind of button that the US president would have for like launching nuclear warheads or something like that. So here's an impression of Donald Trump pushing the nuclear button. And here's an impression of someone competent doing it. There you go. You can see the LED lighting there as I push the button, so that's working. If I switch the LED so that it's the other way around, doesn't light. So you can see nothing going there. Switch it back. So you can see that's working. And then if I did, this would be a very odd circuit to build. But if I put this here and then this one here, like that, nothing doing. So not going to work. LEDs are pretty cheap, so I'm not too worried about damaging that there. They cost less than a penny each, those ones. But be cautious if you're ever doing anything with the more expensive ones. Blue or white ones cost more than red. Red are, like myself, a bit cheap.